Hi, it's Chris. We're taking a look at question 30 in section 4 of SAT Practice Test 2, and this one's a doozy. I will I will just say that it's what I like to call a true 30, which means since the math goes easy to hard during the section, in theory, as you get to the tail end of the section, you should be getting to the hardest questions. In this, in fact, it's the last multiple choice question, and I think it is the hardest question for this particular math section. So let's dive into it. The figure above shows a regular hexagon with sides of length A, so we can label that, and a square with sides of length A, which kind of makes sense because if you look at this side here, you see that that's a side of the hexagon and a side of the square. So everything's got a side of length A. We don't have to label them all, but we know that they're all A for the side length. Okay. The area of the hexagon is 384 root 3 square inches. What is the area in square inches of the square? Okay, so first, let's talk about using a little bit of strategy to try to make this question a little bit more manageable. So keep in mind this is the calculator section. So 384 root 3 is the hexagon, and let's look at the square compared to the hexagon. So it's definitely smaller, but let's think about how much smaller. If we look at a couple of our answer choices here, so answer choice C and answer choice D have the root 3 with them, just like this does. And we're looking at 64 or 16. So if you were to divide 384 by 16, that's 24. So this square, if you picture placing this square in the hexagon, and I'm going to cheat a little bit just because we have the technology to do it. So your test day approximation might not be quite as exact. But if I were to take this square and just move it inside the hexagon, I can see about how much space it takes up. It's smaller than 384. But if I did 384 divided by 16, I get 24. So this is like for answer choice D, saying that the square is 1/24th the size of that hexagon, or that I could fit 24 of those squares in there. And is that realistic? Definitely not. I don't even think I could fit 2 squares in there, but maybe it'd be close if you, like broke it up and, used it to fill in all the edges and so forth. But 24 of those, definitely not. How about 384 divided by 64? Let's see what that comes out to. So that would be 6, which means they're saying the square is 1/6 the size of that hexagon. And again, here, if I look, I could, break up a square into smaller pieces and, try to fill it as efficiently as possible. I could maybe fit 2 squares in there, or 2 and change, or 3 potentially, but definitely not 6. So we can eliminate answer choice C as well. Again, this is one of the hardest questions that you'll see, and if you can 50-50 one of the most difficult questions relatively quickly without having to do any calculations, then you're definitely going to be ahead of the curve. So that's the right way to think about how to process questions logically. But 256 and 192 are pretty close, and it might be a little bit tough for us to, pick between those two without having to do a little bit of math. So now let's see the math approach to this question. So any polygon that you see, you can break up into a certain number of triangles. If you put a point in the center and you draw lines from each of the corners, so each vertex to the center, you can break it up into triangles and see how many there are. And we can work within one of those triangles, because now if we do 384 divided by 6, so we're going to end up with 64, which means that each triangle is going to have an area of 64 root 3. So same thing here, 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 and here. So all the way around, 64 root 3 for each triangle as its area. So now let's see if we can get some values from that. And here there is a piece of outside content information that we need to know, which is that to figure out the sum of your interior angles, you're going to use a formula, and it's going to be 180 times n minus 2. That's going to be the sum of your interior angles. So for a hexagon where you have 6 sides, that would be 180 times 4, which gives you 720. So I'll put a little asterisk here and highlight this, but this is definitely something that we should remember for the sum of interior angles for any polygon. We probably already know triangles or quadrilaterals, but when you get to 5, 6, 7, 8, 9, 10 sides, it's good to have a formula in place for that. So here, that means the sum of all these angles would be 720. And since it has 6 sides, you could divide that by 6, and I'll write out the math up here just so we can see it all, but that would be 720 for the sum of the interior angles, and then 720 over 6 would tell us each one is 120 degrees. So that means this entire angle here would be 120. And then for our triangles, it's also great information because it also tells us that for each triangle, we got 60-degree angles here and here and up here. This is an equilateral triangle, 60, 60, 60. And for any equilateral triangle, so again, there's a lot of outside knowledge here to do the exact math on this question, but we can break that up into a 30, 60, 90. And now we're talking. Now we're in business, because if the entire side length is A, then we can figure this out. This would be A over 2. This diagonal here would be A. This height would be A root 3 over 2. So if you don't have your special right triangles memorized, A, memorize them. And B, they do give them to you with your little cheat sheet at the beginning of the section. But if you're looking to tackle a question of this level difficulty, if you're looking to invest the time to answer a question like number 30 out of 30 in this multiple choice section, then that is something we should have memorized. But here, now we have a base. The base of this triangle is, it's A over 2 for each smaller piece, which means the entire thing together, right, is A, as they told us. The height is A root 3 over 2. And if we have a base and a height, and we know the total area, which is 64 root 3 for each of these triangles, now we can set up an equation and start solving. So here, your area of a triangle is 1/2 base times height. Again, you should definitely have that memorized, but if you need to use the cheat sheet to follow along, you can. That area we found to be 64 root 3. 1/2 times our base was A. Our height was A root 3 over 2. And now we have one variable, which means we could solve for A. So here, as we go to solve, we get 64 root 3 equals, this is going to be A squared root 3 over 4 when we multiply those denominators. And so the root 3's can cancel, and we can multiply both sides by 4. 64 times 4 is 256 equals A squared, which means that A is square root of 256, which is 16. And again, back to our original, but since they told us that one side of the square was A, that means that this is 16. So each side of this square is 16. And the question, let's see what they're asking for just to make sure. They want to know, what is the area of the square? 16 times 16 gives us 256 for that area. So like I said, this is definitely a true 30. It's a very difficult question. This is all the math for the question, but even more importantly, probably as a takeaway, is that even on the test's most difficult math questions, we can sometimes use a little bit of spatial awareness to try to figure out if this is about the size of the square, how many of those squares could fit within that hexagon, and what's the ratio or relationship of the size of the square to the size of the hexagon that they give right here in the question. If we can do that, we can maybe 50-50 one of the most difficult test questions that we'll see. And if we have the background, like sum of interior angles or a little bit of special right triangles knowledge like we see in here, then we can confirm and